Speed versus velocity. First, we need to figure out what the difference is between speed and velocity. So speed is the rate at which an object is covering a distance. As we said before in previous lectures, distance is a scalar unit, so that means speed is also scalar, meaning direction does not matter. The value is not dependent upon direction at all, which also means that speed cannot be negative. If an object is moving and has speed, it is a positive value. Velocity, on the other hand, is the rate at which an object changes position. We don't use velocity often in our normal everyday lives, so it's kind of hard to grasp, but it's how long it took to get to your final position, no matter how many twists and turns you took to get there. If you were to just go straight from your starting spot to your final ending position, what speed would you have been moving to get there? Velocity is vector, so direction does matter, which also then means that velocity can be negative. Just like with displacement, the sign of the velocity just signifies direction, not how quickly or slowly the object is moving. A negative velocity does not mean it's moving slowly, it just means it's moving in a negative direction. So if we look over here, we can have two different cars. If they're exact same, they can both have a speed of 300 kilometers per hour, even though they are driving in opposite directions of each other. However, the car that is moving to the right would have a positive velocity of 300 kilometers per hour, and the car that was moving to the left would have a negative 300 kilometer per hour velocity. Note, the speeds are the same. Speed is going to use distance, velocity uses displacement. For both speed and velocity, the unit that we are going to use is a unit of distance, a mile, a kilometer, a meter, a centimeter, a foot, divided by a unit of time, hour, minute, second, day. So they both have the same, they're going to have the same unit, whether we're talking about speed or velocity. And here's our two new equations. Calculate speed, we use speed equals distance divided by time. Whereas to calculate velocity, we're going to use velocity equals displacement divided by time. And don't forget, we still have that previous equation that displacement is your final position minus your initial position. That is still going to be coming in play, especially with position time graphs. So here we have an example. A swimmer takes 72 seconds to swim exactly 100 meters up the pool. What is the swimmer's speed and what is the swimmer's velocity? So first thing I would do is list out my variables for speed. I have a distance of 100 meters, a time of 72 seconds. So my speed is going to be 1.39 meters per second. For velocity, I am going to also have 100 meters. Since it says up the pool, up is considered a positive value. So no matter what, because they only did one lap, they went from one side to the other, they went in one direction, in a positive direction, both my speed and my velocity are going to be identical. Now let's take this one for example. What is the speed and velocity of a runner that travels from the 6-yard to the 2-yard line on a football field in 3 seconds? So our knowledge of football, or hopefully our knowledge of football, would tell us, or even just a number line, that if you go from 6 to 2, you will be going 4 yards over a time of 3 seconds. So the speed that that player did was 1.33 yards per second. For my velocity, however, because I'm given positions, my initial starting position was 6 yards, the final position was 2 yards, the time was still 3 seconds, but that's going to change my velocity into a negative value because it's going to be 2 minus 6. And this is only because they're moving in a negative direction. All right, take a minute and see if you can figure out what the answer would be for the following question. Cross-country skier travels 800 meters right, 140 meters left, and 100 meters right over the course of 3 minutes. What is their speed and what is their velocity? Go ahead and pause the video and then we'll go over the answers. All right, you should have had that they traveled a total distance of 420 meters, so that's 180 plus 140 plus 100 over 3 minutes. So they had a speed of 140 meters per minute. However, for their displacement, they went 180 to the right, 140 to the left, so we're going to subtract that value, plus 100 meters to the right. So they have a total displacement, meaning when they stopped moving, they were 140 meters to the right of where they started. So their velocity is actually going to be 46.7 meters per minute. Okay, so let's go ahead and do a practice problem here. If you drive 100 kilometers per hour for 6 hours, how far will you travel? First thing we want to think about is, are we doing speed or velocity? Since we're not given a direction, we know we're going to be doing the speed equation. So I'm going to list out the variables that I know. I have a speed of 100 kilometers per hour, and I have a time of 6 hours. So to find my distance, I'm going to cover up the distance on my little triangle here. So it's going to be speed times time. So the distance would be 100 times 6, or 600 kilometers. Take a second, pause the video, and work through this one. All right, you should have gotten that the time was 1.5 hours. The velocity was 4 miles per hour east, so we know it was positive. The displacement was 6 miles because that's how far away it was. And so we're going to do our displacement divided by our velocity, which gives us 1.5 hours. All right, here's another one. All right, if you worked through this problem, you would know that velocity would be the equation that we would be using because we're driving up to Boston. The velocity was 105 kilometers per hour. The time was 6.2 hours. So to find my displacement, I would have velocity times time, which gives me 651 kilometers, excuse me. Okay. One last one, and this one's going to be a little bit longer to think about, but what is the velocity of a trip that takes 10 hours and covers 325 miles east and 85 miles west? Take a minute, work through this one. Okay, and for this one, you should have gotten a velocity of 24 miles per hour. To find our displacement, we would have done 325 minus 85 because it was 85 miles west, which gives us a total of 240 miles for our displacement. We have a time of 10 hours, and it's going to be displacement divided by time, so 240 divided by 10, which gives us 24 miles per hour. All right, so let's go ahead and look at how we can use these equations with a position time graph. So using the positions from the y-axis and the amount of time from our x-axis, we are able to find both the speed and velocity. So if I wanted to find the speed and velocity of an object that traveled this distance, so for my speed, I would have to figure out my total distance, which would be 15 minus 5, because it started at 5, so it went a total of 10 meters in a forward direction over the course of 20 seconds. So then I would do 10 divided by 20, which gives me a speed of 0.5 meters per second. In order to do the velocity, I would look at the position, my XO and my XF. My XO is 5, my XF is 15, my time is still 20 seconds. So in the end, I am still going to have the same velocity as my speed. So because it's moving in a positive direction and because we're only working with straight lines, it will always be the values, the numerical value between 2 points will always be the same. The only question is whether or not it will be a negative for your velocity. Okay, let's do this one using another position time graph. So I'm going ahead because I know it can be a little bit hard to read sometimes, but I give you the distances of the two different sections of line. So take a second, pause the video, and go ahead and solve for speed and velocity. All right, now in this case, because the object changes direction, my speed and my velocity are drastically different. The distance the object is traveling is 13 plus 9, so it travels a total distance of 22 meters over the course of the 10 seconds. So it has a 2.2 meter per second speed. My velocity, however, again, displacement is only focusing on how far away are you from your original starting position. It started at position 1 meter and it ended at position 5 meter over the course of that 10 seconds. So it's going to be 5 minus 1 divided by the 10 seconds. So the velocity is actually 0.4 meters per second. All right, last one here. Go ahead, pause the video, find the speed, and find the velocity. Okay, so for this one, we have the speed is 17 plus 12 plus 7, which gives us a total distance of 36, divided by the 20 seconds. So we have a speed of 1.8 meters per second. But when we're looking at our velocity between A and D here, we have a starting position of 20, an ending position of 8. So that's going to mean that my overall velocity going from position A to position D is a negative value because my object is starting further down, it's ending further down than where it started. So we have that negative value because we moved down the y-axis. So we would do 8 minus 20 divided by 20, which gives us a negative 0.6 meter per second.